again. In this lesson, we're going to talk about how we can actually create two speeds in a consequent pole motor. Now, a consequent pole motor is also known as a one-winding two-speed motor. It allows us to actually produce two speeds off of the same motor because it uses the one winding. The concept here is we're going to make two different types of connections, and your starter actually does this for you. We're just going to kind of break it down as to what the starter is doing in its most basic form to create those two speeds. The first thing to remember is that whenever we have a high speed, so the high speed between those two speeds that are listed on that motor nameplate is created when the starter itself connects for a conventional connection. Now, if I was to give you some sort of an explanation as to what a conventional connection means, it really means that we're going to cause current to flow around each part of the winding. In this case, we're showing a winding here and we're showing a winding here. And what we're going to actually do is we want to make it so that current is flowing the same direction around each winding. Okay, so there's two ways in which we can do that. We can either make a series connection, which again, your starter does this for you, but when it does, it's either going to make a series connection or it's going to make a parallel connection. Now, in order to determine rather whether we make a series or parallel connection, we have to take a quick look at how each one of these windings is wound. Are they wound the same direction around each pole, or are they wound in different directions? So on the one on the left here, you can see that if we were to make a connection here, this particular winding is wound clockwise. So is this one down here. Now when we go over to this one, you can see that this winding is wound clockwise. However, they reversed it over here, and now we have a winding that is going counterclockwise. Now that's going to affect how current flows. So here's our example. What we're going to do is we're going to start, and I'm going to use black here just to indicate our negative and positive. Now understand that we're going to be hooking up, or the starter itself would be hooking up an AC supply. We're going to freeze frame that AC supply for just a fraction of a second and evaluate using electron flow. We're going to look at current flow going from negative to positive. So when I hook up or apply that voltage across that particular winding, current now is going to flow this direction here, like so. It's going to go clockwise around this guy, and if we follow it down, current is still flowing, and we end up going clockwise rather around this guy because both of these windings are wound in the same direction. Now this is at the point where we have to remember our left-hand rule for conductors. If we use our left hand, what will actually happen is we can identify where we're creating a north and where we're creating a south pole. We're going to start with the top winding first. Using the left-hand rule for coils, that means this will produce a north pole right here, which of course means that that produces a south pole right there. Now let's evaluate the bottom part of this coil. As current flows, we're going to use the left-hand rule again. Well, that means we actually end up with a north pole down here, which means the result is a south pole right there. Now, understanding that actually our rotor bars, our rotor winding is in this area here, this shows us that we end up getting an electromagnet where we have north flowing to south. Okay, so our magnetic lines of force are traveling north to south. The conventional connection by creating one north and one south pole in this area means that we've created a conventional connection. Okay. Now, the next step, we're going to go over to this next one. Now, just remember, when you take a look at this, this one is wound a little differently than this guy. Over here, we still want to make a conventional connection. In other words, we want current to flow the same direction around each winding. Now, that doesn't necessarily mean that it would go clockwise in both directions as this one. It might go counterclockwise on both of these windings. It doesn't matter as long as the current flow is the same direction around each one of these poles. We're going to end up producing one north and one south pole. In order to do that on this particular one, instead of making a series connection, because they're wound backwards or opposite to each other, we have to make what's called a parallel connection. And this is what it looks like. So I'm going to actually take and I'm going to connect a line from there to there. Okay, we're going to terminate that right there. And then we're going to bring this guy out like this. So I'm going to terminate right there. Okay, so that's, remember, this here is all one winding. So what we did is we kind of took a hook and we hooked that chunk out over here to where we can deal with it. Now we're going to do the same thing that we did on the left. We're going to assign a negative polarity here, and we're going to assign a positive polarity here. And then we're going to evaluate current flow. And again, I'll use red to indicate our current. Now, here's what happens. So current flow, like it did on the left, is going to start out, we're going to have current flowing down this wire. Except this time it reaches a junction point, and that current has no choice but to split and go two different directions. Okay, so I'm going to split it, and we're going to go two different directions here. And we're going to start with the top, and we're going to see what direction this current is actually traveling around this coil. Well, if we follow it in behind here and come around, that means that our current flow is actually going counterclockwise on this particular winding. Okay, now let's take a look at what's happening down below. Again, we're going to follow current here. So we follow it around behind, and it's going to come out here. Well, lo and behold, by making that parallel connection, we actually caused current to flow the same direction around each winding. Now again, you might be asking, well, how did that happen? Don't forget, this bottom winding was wound in the opposite direction to this guy. Had we made a straight series connection here, we would have ended up with this guy going clockwise and this guy going counterclockwise. And we're going to get to consequent poles here in a minute. But the end result is, again, if we follow this through, using our left-hand rule now, that means a left-hand rule for coils, we're going to create a north pole up here. I wanted to use black there, didn't I? So I want to create, or using left-hand rule for coils rather, we're going to create a north pole up here, which means we create a south pole here. And again, we're going to use the left-hand rule for coils down below. We're going to create a north pole here, which means we end up with a south pole right there. Now we have magnetic lines of force traveling north to south. We have created one north and one south pole in the region of the rotor. And that is called a conventional connection. And again, don't forget that whenever we create a conventional connection, that connection, by making a conventional connection, will give us our high speed.